Hello everyone in CSC-134, C++ programming. We're finishing up uh, Module 5 on functions this week. Last week we talked about all these bulleted items on the checklist. Um, the static variables are pretty useful when you need something to stick around from one function call to the next. As you may remember, the lifetime of a variable that is declared inside of a function is only as long as that function is running. And so from one call to the next of a function, whatever values are in those variables goes away because they're destroyed unless you make them static. So we also talked about the differences between global and local variables and how that impacts whether they're initialized or not. You may remember that while global variables, that is variables that are not declared in any inside of any function, they are initialized. Most variables that we use by good practice are local variables and they are not initialized. So two differences there involving global and local variables from last week. So this week we can probably have just one lecture and cover all this material, but we'll see how the time goes. I try to keep the lectures down to about 40 minutes or less. So, function overloading. We don't have function overloading in Python, so this is one instance where C++ has an advantage over Python. The ability to overload a function can really simplify the way your program is written. I'm going to click into that lecture in a minute and we can talk about that. But before we get into functions, there was one thing that we didn't really talk about last week, and I did want to go over it, and that is that you can have parameters that have a default value. So I'm going to open up a little program that I have here that's from page 353 in your textbook, and we'll look at that program and talk about it a little bit. So this is the program from page 353 in your book, and I'm going to call some things out to you. This is the function prototype for a little function that is named display stars. And basically what this does is it displays a number of asterisks depending on how many you pass in these parameters. Now you may remember that when we do a function prototype, at least was the way we did them in the previous week, this stuff right here that I'm highlighting, this equals 1 or equals 10, was not there. Okay? So what's going on with this in the function prototype where they have equals 10 and equals 1? Well, those are what we call default values. So if we call display stars and we don't supply anything, as the way this is written, both parameters are default values. If we don't supply anything, C++ is automatically gonna plug a 10 into columns down here. You can see where I'm getting that in the columns. It's going to automatically plug a 1 into rows if we don't supply anything. So you see right here they're calling this display stars function, and even though it is here in the function header, or what we call the function signature, even though it has 2 parameters defined, int calls and int rows, because we did this with the prototype, it's going to let us get away. We'll be able to get away with leaving these out because there's a default value supplied up here. So I'm going to build this and then run it so you can see what it does. And here's where it's running. And you can see here that this is the result of the first call right here. This is the result of calling it the first time. And you'll see it has 10 stars and one row. Okay. Now, here's where we call display stars with a 5. So what did it do? It printed 5 stars. So if you'll notice, the first thing that's supplied automatically takes the place of the first things here. Okay? If you wanted to write a program, you couldn't make this one the optional. You couldn't make this one the default parameter. You'd always have to supply at least 1 here for it to ever get to this one. So if we supply something, it automatically goes from left to right, so it starts filling it from left to right. So that's why it printed 5 stars here, but it automatically applied 1 row to it. Okay? So, and then of course here's another call to it where they supplied both the columns and the rows. And so this call should get us 7 stars in a row and 3 rows. So there's our 3 rows right here, and there's our 7 stars. So this is the way that you do an optional, or what we call a default parameter. Now, one thing to keep in mind with this, you want to do this in your prototype. Don't do it down here where we're actually declaring the whole function. Okay? This default value stuff needs to be at the top of your program. If it's not at the top, you may not get it down here. So always, always, always put your default values or your default arguments in your function prototype. Your function prototype is going to be at the top of the program. So that's a little bit of a talk about default arguments. Your book will tell you, and you'll probably have questions about it on your exam, that the function's default arguments should be assigned at the earliest occurrence of the function name. And then, like I said, that's usually the function prototype. Also, if you leave an argument out of a function call, all arguments that come after it must be left out as well. That's going back to what I said about it fills from left to right. So if you want to leave the one out on the left, you've also got to leave the one out on the right of that function call. So when a function uses a mixture of parameters with and without default arguments, the parameters with the default arguments must be defined last. So what that's saying is, if we want to have a default argument for just rows, then we define it last. This one is required now. Our program would blow if we tried. It would blow on this line right here because it would say we're not supplying an argument. Let's just try building it and see. It says compilation failed, okay, and it's talking about when we supplied too few arguments to it. So that's because I have one that's required, and I have one that has a default value that makes it optional here. So the ones with the optional parameters or default arguments, whatever you want to call them, are always defined last. Always defined last. Okay? All right, so enough about the default values. Let's go on and talk about function overloading. So I'm here on the checklist, and you can see right here well, it shouldn't be number 9. I'll have to go in and work with that. Sometimes when you have bullets in here and you make these things in Blackboard, it loses its little mind here for the numbering. So this should be number 2 where it says function overloading. Hopefully I'll be able to get that fixed. So here's the lecture on function overloading. So what does this do for us? It lets C++ automatically pick the best function. We can name a function. We could have 3 versions instead of doing like we've got going on here where they did an add for ints, or right here where they did an add for integers and they did an add for doubles. Okay, instead of having to name these things differently and keep track of what we wanted to call the add function against, whether it was an int or a double, we could actually name both of these functions add, and C++ would be fine with that because the parameters are different. Okay, you notice how we've got an int and we've got a double. You may remember this line is called the function header or the function signature. So what C++ would do is, if we had both of these things in our program and they were both named just add, it would look at what you had passed to it. If you called the add function with integers, then it would use this version. If you called the add function with doubles inside the parentheses, it would use the double version of your function. So it can make your program a little bit easier to write by using overloading. And so the lecture goes through a whole bunch of stuff talking about an ambiguous match, as if there's no way for C++ to tell which version of that function it should use. And that can happen. That can happen if it doesn't match up exactly. Okay, now notice here we've got two versions of print. Okay, we've got one that's expecting an unsigned int. We've got another one that's expecting a float. Okay, if we tried to call it with a character value, then neither one of these versions has a character parameter. So what C++ is going to do, it tells you right here, if it can't find an exact match, it's going to try promoting the character to an int. Okay? But there's not really just an int value here either. There's an unsigned int. So it can't convert A to both an unsigned int and a floating point value. Okay? Because all the standard conversions are equal. In other words, converting this a standard int, or excuse me, a standard char to an int, it can't do that. And these are both at the same level, so it doesn't know which way to go. And it will not compile. It will tell you that there's an ambiguous match. So it goes through a whole bunch of promotions here. I'm going to download this so we can and open it up in Genie so we can look at it. Let's see, function overloading. There we go. All right, so I'm going to open that up in Genie. All right, so we've got it open. And how many versions of this function FCN do we have? We have one version that works with integers. You notice it's got void here, which means none of these three are going to return anything. They're not going to return anything. But we have one version of FCN that takes a character and an int, 2 parameters. We have another version that takes a character and a double. And we have another version that takes a character and a float. Okay? So, this one right here, when we call the program and pass a character to it, that's going to match all three of these, right? So which one's it going to use? Well, we're passing a 4 to it. So it's going to print an A out. Let's build this and we'll see. Okay. I'm going to run it. You see it printed an A. Okay. That's because this 4 matched the int exactly. Now if I change this to a 4.0, what do you think it's going to do now? Well, C++ will automatically assume that if you put 4.0 there, it's a double. It's always going with a double unless we force it otherwise. Okay, so if that's true, that it's always going to consider this to be a double, then it should print out a B if we compile this and run it now. And what did it print? A B. Okay, so how would we ever get it here to the float? I think, if I remember right, if we put an F on the end of it, that says that's a float literal. And now we've changed this from being just a 4.0. It considers it to be a double. I've made it a float. So hopefully now when we run this, we should see a C come out. And did we? We did. So that's function overloading, making the program. You don't have to remember which function you need to call, because we've done this and we've written 3 separate functions down here. So we let C++ pick the best function to use based on what we're passing it. Okay, and remember that it looks at the function signature to decide which way it's going to go. Looks at the function signature to figure out which way it needs to go with that, which function it's going to pick. Okay? All right, so one last thing that's not in your book at all. Nothing in your book whatsoever about function templates. So with a function template, you saw when we were just working with the overloaded functions here, okay, we were working with these. We had to write that function 3 different times, didn't we? Even though, even though all we were doing is printing out a different letter each time, okay? So this wouldn't be a good candidate if we're printing something different out each time for a template. But if we needed to do the same thing, whether it was a integer, a float, or a double, if we needed to do exactly the same logic for all of them, and just obviously if we were taking int in, we'd probably want to return an int more than likely. If we were taking doubles in, we'd probably want to return a double. If we were taking floats in, well, we might want to return a float. So instead of having to write the function 3 different times, there's something that's really handy that I've used in the past, and it's called a function template. And so here's the lecture on function templates. And they do look a little strange when you first look at this form, okay? This is valid C++ code, and if we put this up at the top of our program, then the compiler will actually generate a function based on what we're doing with that maximum function when we call it. So here's an example. I'll go ahead and download it so that it's a little bit bigger. Okay, I'll download it same place. Okay, and then I'll open up that function template demo. All right, so here it is, and like I told you, it goes at the top. It has to be at the top because C++, the compiler and the preprocessor primarily is going to look at this, and it's actually going to write a function based on what we're doing down here in our program. So we've written this code once to find the biggest of 3 values. Okay? So it doesn't matter whether once we've done this template, we could use this with ints, we could use this with doubles, we could use this with characters. It does not matter. C++ will write the correct code for us if we put this template in our program. Now, if we were doing it this way, we would have 3 different versions of the function down here that we would have to write. But because we're doing it this way, we write it one time and C++ takes care of the rest. So check it out here. Okay, here we define 3 characters. We ask the folks running the program to key 3 in. Okay, here we're capturing them. And then look what we're doing. We're calling maximum and we're passing 3 to it, 3 characters to it, it's going to automatically create a maximum function for character values. If we're doing integers, and see the compiler sees this, it'll automatically go find that template, and it will create a function for us that will take integer parameters in, and it will return an int. Okay, so very powerful stuff here. Not in your book anything about function templates, okay, but very, very powerful stuff that as long as you've got to do exactly the same thing, you know, here we were doing exactly the same thing, right? We wanted to find the biggest thing out of 3, okay? So it doesn't matter whether it was an int, a double, or a character. This would work to find the biggest of the 3. You could write another one that did the lowest of the 3. You know, what would we do? Well, obviously we'd probably change the name to be lowest or minimum or something, okay? And then we always save the first one, right? Save it. If we were doing minimum, we'd save the first one as min. And then here this would change to a less than. So if value 2 is less than the min, then make minimum value 2. And then here, if value 3 is less than, remember we changed that because we're talking about doing a minimum. If value 3 is less than min, then make min value 3. And it would not matter whether we were working with integers, doubles, or characters. This would work. We just call maximum and everybody would be happy. So you see it compiled fine, and I'll run it. Okay, here's input 3 character values. I'm going to put a W, a Y, and a Z. Okay, you see it found Z as the maximum. Input 3 integers. Okay, well let's do 50, 2, and a 100. And you see it worked for the maximum integer. And now the last one is doubles. So 300.9, 100.2, and 400. No, let's make this one less. 50.9. Okay. And you can see it found that. So regardless of what we passed to it, it automatically knew what to do with it. And so that's a pretty cool way. It really made this program. This would have been a long program otherwise, wouldn't it? If we were just doing overloading here, then we would have had to have 3 versions of this function. 3 versions. We'd also have had to have 3 prototypes. And so, you know, this is a lot shorter and a lot more powerful. Okay, so that's the end of this material on function overloading, function templates. You'll notice that there is a project 8, and we can go check on project 8 and see what that's all about. Project 8. And I think that's the one that we were already working on. Yep, so you already know about project 8. Now you could do some of project 8 here. Check it out where it's doing find lowest. You could do a function template for that if you wanted to. It's up to you. Okay, well, good luck this week. The exam is available, and if you run into something with CodeLab, let me know, and I'll try to get you some help with CodeLab. All right, have a good week.